Hi class, this is Neil, and this is lesson 2 of unit 10 on complements, intersection, and union. In this lesson, we'll go a little deeper into probability and the events that probability help describe. We'll actually be splitting this lesson into 2 days worth of work, so we won't cover everything in lesson 2 today. We'll cover about half of it. So first of all, a complement. So a complement describes all outcomes that are not the event. We'll look at an example in a minute that will make this a little bit more concrete. But the way that we describe the notation for the probability of a complement of event A occurring is this symbol P of A with a little apostrophe. That means the complement of the event. So I'll go ahead and write kind of what that P of A prime, what that describes under where we see notation. So again, that P of A prime describes the probability of the complement of event A occurring. All right, so let's look at an example of this. I'm going to describe an example first. So if event A is rolling a 5 with a die, what would A prime describe? Well, A prime would describe all the outcomes that are not rolling a 5. And so with a dice, that would be the numbers 1, 2, 3, 4, or 6. That's all the events that are not a 5. So let's consider this example. So let's say that within a sample space, we had a possible number of events of 1 through 10. And I'll just record that here. So that's everything in our sample space. Now, we're also going to say that A is going to be a set of integers that are in S that are even. So A is the set of all even numbers between 1 and 10. So that would be 2, 4, 6, 8, and 10. Now B is going to be the set of all integers that are multiples of 3. So B describes all the integers that are part of S that are multiples of 3. So that would be 3, 6, and 9. Okay, now I'll just write in words kind of below each of those what they're describing. So all integers even, and this is all integers that are a multiple of 3. I'll just write M3 for multiple of 3. So that's really defining what our set is. So we're going to use that Venn diagram there to describe what's happening in that sample space. Okay, so first of all, set A is going to be all the numbers that we've listed here. 2, 4, 6, 8, and 10. Set B is 3, 6, and 9. Now notice those two sets share 6. And so when I'm drawing out my Venn diagram, I'm going to include 6 right in the middle. For A, I'll include everything but 6 because we've already included it in the middle of our Venn diagram. So that would be 2, 4, 8, and 10. For set B, I'll include 3 and 9. Now notice A and B, they share 6. So that's why it's in that intersection of those two circles. Now, we need to account for everything else that is not included here. So that would be the number 1. That would be the number 5. That would be the number 7. And that's all, right? So let's just make sure we've included everything between 1 and 10. And we have. All right, so let's look at our probabilities here. So determine the probability of A. So P of A is going to be equal to everything that's in set A. So everything in set A is 1, 2, 3, 4, 5 over the total probability of this entire sample space, which is 10. So 5 out of 10, or 1/2. Okay, the probability of B. Well, the probability of B happening is everything that is in our circle B or in our set B. So that is really 3 out of 10. Okay, so next we're asked to determine the probability of not A. So that PA with a dash means the probability of it not being A. And I indicate that with that PA with a dash. So probability of not A. Well, we have 5 things that are in A. What's not in A is 3, 9, 7, 1, and 5. So that is also 5 out of 10, or 1/2. The probability of not B. Well, the probability of not B is everything that's not in B. So that's going to be 7, 4, 10, 8, 2, 1, and 5. So that's 7 out of 10. Okay, for part C, we're asked to shade in the overlapping section. So that's that 6 there. And what does this section represent? Well, we already kind of discussed it. It represents what set A and set B share. And we're asked, what is the probability of choosing a number from this section? Well, there's only one number in that section. So the probability of that would be 1 out of 10.